Joining me on the stage is Mike Schuster, who is joining us from Two Sigma. To give a little bit of background on Mike, Mike joined Two Sigma in New York as the head of the AI core team in 2018 and is a managing director where he has been working with a growing team of AI researchers on challenging machine learning problems in the financial space. Mike has a rather illustrious career prior to that in AI. Previously, he was part of the Google Brain team in California, where he co-led development of the new Google neural machine translation system, worked on large language models, and also worked on human-like speech synthesis. Earlier at Google, he did research and development on all aspects of speech recognition, on Android, including launching the first versions of the Japanese and Korean speech recognition models, working on YouTube recommendation systems, and many other machine learning related projects. He was also an early contributor to Google's open source machine learning toolkit known as TensorFlow. Mike's 25-plus year professional career brought him to the Advanced Technologies Research Laboratory in Kyoto, Japan, Nuance in the United States, and NTT in Japan. Mike holds a PhD in information science from the Nara Institute of Science and Technology in Japan and a master's degree in electrical engineering from Gerhard Mercator University in Germany. Thank you for joining us today, Mike.
Thank you. That was quite a summary. Yes.
So you've had a long journey to get to where you are today. Can you tell us a little bit about your personal journey in artificial intelligence?
Yes. So I grew up in Germany, as you found out from the introduction, and I moved to Japan. I got my master's. I studied electrical engineering in Germany, and then went to Japan. Worked as a researcher in an AI lab. Where I started, I learned a little bit about speech recognition before that, and I did my PhD also at that time. And then, there was a little bit back and forth between Japan and California. And eventually, I ended up at Google in 2006 and worked on a lot of different things at Google on speech recognition, on machine learning, on neural networks, on TensorFlow, on translation. And eventually, in 2018, decided to come to Two Sigma because, Two Sigma was interested. I was interested in finance. I thought it was a really interesting field altogether. And one thing I saw was that all the improvements that had been made in all these systems in tech, in speech recognition, translation, image, games, and there were many other areas. I thought, and Two Sigma thought, that some of that we could do in finance as well. And so the group that we have now is called the AI core team, is exactly focused on that, to basically use as much as possible the latest technology on problems that we identify in the company, in finance, and solve them better than what we had done before. And it has been quite successful, I'd say. Two Sigma was great for me. And we hope to do this for a long time.
Right. So I think you've had two probably quite different and sort of simultaneously very interesting viewpoints. Having been at Google, that's obviously one of the leaders in the development of artificial intelligence. Going back historically, but even more recently, ideas such as Transformer came out of research at Google. So you have a leader on the technology AI side on one hand. On the other hand, I'm looking at a place like Two Sigma. Two Sigma is clearly a leader in applying systematic and quantitative techniques in investment management. And your career has spanned both of these illustrious places. How is AI R&D different in the financial world versus the big tech world?
Yes, that is a good question. A lot of people from tech asked me, so you went to finance, what is actually the biggest difference, right? And first, the one thing that I noticed first is just the number of people. At Google, they have, when I joined, there were 5,000. When I left, there were 80,000 in 2018. Now they have 180,000. At Two Sigma, we have 2,000 people total, right? And some of those people work on very unrelated, they don't work on the quantitative management side. They work on something else. So the number of people is maybe the biggest difference. It's just a much smaller company. You know the faces. You see people in the lobby, and there's only one team for one thing, and not maybe 5 teams like at Google in some cases. So that is one difference. Another difference is, I'd say, the uncertainty. In one thing that I've noticed is when you work in tech, I mean, research is complicated, but there's an abundance of data, and the models are huge, but you don't really have a problem of not having enough data in tech. And that is on the training side, and actually on the, what we call inference, on the usage of these models as well. To give you an example, if you build a speech recognition system and you build something and eventually you want to test it, you can collect more and more data to be certain that it has statistical significance, whatever changes you made. So in finance, there's also a lot of data. It's very messy, but there's only one day at a time. And I often give the example, if you want to predict, let's say, the stock price of Apple tomorrow, you need a lot of data to do that correctly. You only have 250 data points a year. That is not usually enough to build a good model. And so that's on the training side. On the inference side, you need to potentially wait a very long time until you can test a model. You cannot just do it for one day or 1 week. This takes potentially years to really test this. And that is, this kind of uncertainty was interesting to dive into, right? Because everything you do is a lot more uncertain, right? So maybe one more bigger difference is competition. So obviously there's a lot of competition in tech as well, but it's not as critical as in finance. And I think when we talked last, I gave this example of, again, if you build a translation engine and it translates 95% of the sentences correctly, and then another company builds one that has 96%, you can use either one, it's going to be fine. In finance, there's going to be a difference of 0.5. The mean is going to be 0.5 below and 0.5 above, and that will make a difference eventually. I mean, in reality, it's more complicated than that, but the competition is just much, much higher.
Got it. So I think you're highlighting 2 specific aspects. One is maybe in the financial world, even though we like to think of the fact maybe there's a lot of data out there, in reality, maybe there's not. Right, limited number of trading days, maybe other markets are irrelevant. You go back too far in time, it's irrelevant. Maybe another aspect is there's more of a winner take all type of dynamic in the financial markets. So when you approach building AI models, how do you factor that in? For example, do you deal with having less data by maybe imposing more prior structure on your models as opposed to being purely data driven?
There is some of that. There's prior structure. You share, in a way, a lot of the parameters. There are many ways of doing that. You apply a lot of regularization and things like that. And that is basically the art and science that people who have done this for a long time know how to do, right? And but you're never done with this. I mean, what people call overfitting is easy, right? Because you basically never have enough data, and that is one of the big challenges, I think, in both fields.
Right. What are some big successes of AI in finance in your experiences?
So Two Sigma has, of course, used machine learning, almost since the beginning. And there was a steady increase of more complex technology. And I remember when I came in 2018, some people had used neural networks already, but there was somewhat a stigma of people saying, "Oh, neural networks don't work," and I had actually heard that from people, who work at other companies. And I don't think that, well, today we can say that is not true anymore, right? So neural networks work well in certain areas because they're just general models to predict something, right? And we use them quite a bit, and that is certainly one big success area.
Got it. What about the biggest failures? Maybe not at Two Sigma, but maybe
Yeah, I mean,
broadly.
failures is maybe not the right word. Challenges. Okay,
Yeah.
so challenges. What is difficult about this? And I thought of two things. There are, of course, a lot of technological challenges, right? I mean, to make these things work is very similar, like in tech. You need GPUs that run in the cloud, that talk to each other. You need knowledge about things like TensorFlow and PyTorch, modern tools that are not easy to learn. You need the money to pay for these things. But what you also need is the human factor of this. You also need people who understand all these things, and because it is so complex, one trend that has been happening is that one person by him or herself cannot do these things anymore, right? So it needs to be a group of people, and because of the complexity, and the group of people, to have them work together well, to do code reviews, to be able to communicate, that is, I'd say, quite a challenge in AI in general, not just in finance, but maybe actually in finance a little bit more, because this winner takes all, it's all about me, a kind of attitude is maybe a little bit more than in general than in tech.
So when we talk about a winner-take-all dynamic, it has a little bit of a sound of sort of a zero-sum game. Whereas if you win, then maybe I have to be losing.
Right.
Do you feel that that's really the main place that AI is applying, sort of determining winners and losers? Or, for example, in the earlier panels today, there was discussions of maybe AI could sort of unlock opportunities that weren't there, so perhaps the pie could grow.
Yeah, so I would agree with the second one, right? The pie is growing. So because with AI, at least how we use it, it means that we can do some things a lot faster. We can process more data quicker. We can train models faster and cheaper. We can run more experiments, and that drives that drives basically where we are going. So I don't see really, I don't see really anybody losing in this, right? It's more, and I think, we talked before this fireside chat here. I think this is this thing that has been happening since the Industrial Revolution, right? Things change, and the financial industry for sure has grown. From, I don't know, 2% to 7% of GDP right now, or something like that. That's, again, that is part of this, right? So I don't really see, at least from the people side, a lot of negatives here.
Okay. So one thing I tell my students in the classes that I teach here is when we think of different sort of business domains, finance has probably historically been one of the most analytic and quantitative. And you also alluded to the fact that, for example, neural networks aren't necessarily that new in finance. People have been applying those ideas with maybe varying degrees of success, maybe increasing over time. But certainly it's an idea that's been there. But a lot of that has been focused more on maybe what I'll call analytic AI, maybe using AI to do things like predict uncertain future outcome, or maybe using AI to sort of, given a prediction, figure out how to trade or something like that. Many people sort of feel that really within the past 2 or 3 years, generative AI broadly and LLMs in particular kind of represent sort of a sea change, right? What do you see as the role of things like large language models in finance?
Okay, so when I still was in tech in 2018, these large language models were already developing. And by the way, so language models have been around for decades, right? At least for 50 years. They're needed. They were one of the very important parts of speech recognition and translation engines and of many other things as well. They just weren't as good as they are today. So, and in roughly 2017, 2018, when the first large language models, inside the companies came out, nobody normal knew about it. Nobody outside of the companies really knew about these. But then in 2022, I believe it was when ChatGPT came out, right? And that's what it was like such a huge jump that everybody thought, okay, the world is changing, right? To people who had seen this for a long time, it wasn't that impressive. I mean, because we knew some of that stuff works, some of that stuff doesn't work. But so what can we do today with these models, right? That is an interesting part. I mean, we at Two Sigma define generative AI as one small part, right? But there's a lots of other AI, neural networks and reinforcement learning and whatnot is all out there that is also important. But for the generative AI, so we have used it at least since 2018, and also, general NLP, natural language processing, probably for 15 years or so. But let's see some of the applications that we actually use it for. And one is, and this doesn't apply just to finance or to Sigma, it's just productivity. And everybody can imagine that you can process text better, you can summarize spreadsheets, you can
Coding.
it helps you coding, right? You can tell it, hey, please write me a C++ function that reads data in a certain format, and it will give you something. And that is where it helps quite a bit. So the other part, which is maybe a little bit more specific to finance, is feature extraction out of text and out of other data. And an example that I sometimes have is if, let's say, you have earnings calls or Fed speeches, and you have all the transcripts from all the Fed speeches, you would ask the model, okay, get me all the Fed speeches from the last 20 years. Can I map this on the interest rate change that will follow, right? And you will have to try, by trial and error, you find with the prompts maybe a way to extract features here. And where it really helps here is that this is a much faster way of working than what used to happen. Because how it used to happen was that you had to tell your engineers, please write some code that filter the Fed speeches for certain words or things like that, which was, of course, work and took much longer, right? And that is really helping everybody. And that's where we see right now how large language models help us.
So some of those uses, I mean, like for example, a feature extraction, or again, using these models in the context of prediction, they might be sort of, you might view them as sort of evolution and sort of performing, let's say, natural language processing sort of better than what's in the past. But when I see a lot of the discussions, especially in the sort of computer science community, they sort of view this as maybe something sort of fundamentally different. And in particular, for example, there's this idea of agentic use of large language models. The idea that maybe you can leverage a large language model to do things like reasoning or planning. Maybe you can do that in the context of having external tools like querying databases or writing a bunch of Python and having a Python interpreter run it. What do you see as of the role of agentic AI? Is this something that's real, or is it hype, or?
So, I mean, if you look at the whole of Two Sigma, you can say that is like an agent that does some of these things, right? There's planning involved and reasoning. But if you go to individual large language models, I haven't seen really a tool or an example other than, specific picked examples, right? Those sometimes work. But if you do something more general, I haven't seen anything that is impressive enough to really where you can say this is planning and reasoning, right? And so the world is a too complex place as of right now for language models to understand, for any of these systems to understand. And I'm trying to fight a little bit against the hype that we hear often, from movies or in the media from famous people who are out there and making all kinds of predictions what's going to happen next. Um, when you look at the predictions, many of them are not happening, right? And that's just what we need to keep in mind, that the reality is much more mundane than what a lot of people tend to believe.
Where do you see us as being, as these things evolve? We've kind of seen rapid progress in recent years. Where do you see us as being on the scaling curve? Do you think we'll continue to see sort of these advances based on more data and more compute, or is it more something that's sort of maybe flattening out in terms of those degrees of progress?
Yeah. So one thing I've heard a lot is recently, we need more. We need much larger models, and they are going to use 100 times the energy that the Earth has, and stuff like that, right? And you can say right away, well, how is that going to happen, right? It's not. So what I sometimes tell people is, exponential growth will at some point it will end. It cannot. The exponential growth is by definition will end at some point, right? And so I personally see right now that a lot of people have bought into the hype of large language models, and there's a lot of money spent. What I think will definitely happen is that some of this will become cheaper. More data is potentially going to be used, and the data that is already used is going to be used better, meaning there's going to be some filtering and things like that. The models, I'm not sure they can be much larger, but they will be smarter, right? Maybe you don't have to run for every inference run, as an example. Yeah, maybe you don't have to touch all parameters of the model, right? Which would, I sometimes use humans as a baseline, right? We have a lot of neurons in our heads, and we don't use a lot of energy. So that's where hopefully this is going at some point, and we are very, very far away from that.
Right, and certainly when a child learns to speak, they don't train on trillions of tokens.
That's right. Yes.
So perhaps things can be done smarter. So one sort of question that's repeatedly come up in the panels today is sort of thinking about the competitive dynamics that arise from something like AI. So from your position as a leader in an investment management firm, where do you think the competitive advantages will be? Will it be that a company like Two Sigma has better data? Will it be that you have better techniques to sort of process that data? Will it be that you have a better understanding of how to apply those models in practice? Where's your competitive advantage going to come from?
I think it comes from a lot of areas, right? We have currently roughly 2,000 people that in a pipeline of people coming to Two Sigma, that is hard to build, right? We have 20 plus years of experience with these things that all obviously grew over time. We have spent, a lot of time on technology, understanding the tools, having the right people for understanding some of the AI parts here. What else? I think the experience matters a lot, right? And another thing I can maybe say is, and that has happened in a lot of industries, for example, in the chip industry as well. Every university used to have a chip lab, right? Those days are gone. Today, it's NVIDIA, it's Intel, it's AMD, and a couple of other companies that can actually afford to do this. And it seems to be this growth towards big leaders is happening also in finance.
So that was actually going to be my follow-up question. Do you see the dynamics as favoring larger firms, perhaps firms like Two Sigma, which have the scale? Or an alternative viewpoint might be that some of these technologies might enable younger, perhaps maybe more nimble competitors to sort of emerge that maybe are able to use these models in fundamentally different ways?
I think big companies definitely have, a built-in advantage. But, just as in every other field, sometimes big companies do the wrong thing, right? And we talk to a lot of younger people who have great ideas, um, but the thing is that it's just not that easy to make something work on a big scale, that that you are really happy with and can live on and can run a company on, right? It's not about trading one stock. It's tens of thousands of instruments around the world, and that's just a lot of technology and knowledge is necessary for that.
Got it. One thing that we've been asking in every panel today is there's a lot of students here, and a lot of people are sort of quite curious about how AI is going to change sort of career paths and trajectories, and also what people should learn. So, for example, Aaron Brown earlier this morning made a strong statement that you shouldn't bother to learn to program, that it's irrelevant, that the LLMs are going to do all of that. What do you see as how AI is going to change career paths and opportunities? And in particular, what are the biggest talent gaps that are going to arise? What should our students be focusing on?
Yeah, so let me pick up on that note. You shouldn't learn how to program, and that is basically the same thing as saying you shouldn't learn how to play piano because you have the radio or whatever, right? And I think what you learn through programming or playing the piano, the creativity that you need, and the clarity of thinking, getting used to a longer process of learning something, that is one of the key things that kids need to learn, right? I mean, I'm not calling the students kids here, but like some younger kids even, right? And so the creativity and the interest that you develop in something, that is, I would say, the main, really the main driver of people who are successful in our industry. Of course, it comes along with, with all the hard skills. You need to be able to program. You need to be, um, uh, need to be able to understand statistics. What else is there? One thing I call scientific common sense. If you know a lot about physics, you know what, how to develop a simulator. You have to think about these things, and that requires just clear thinking about a problem. And I said this to you before the talk. I mean, what we are looking for is really interest in the science, interest in the topic. Don't be interested in I don't know, fame or potentially money or things like that. Those things can come too. But the most interesting thing is that drives the progress is really interest in the topic.
Got it. So on that note, perhaps we can move to some audience Q&A. If you have a question, you can raise your hand, and one of the gentlemen with the microphone will come to you.
Awesome. Thank you. Thank you, Mike. I have a question kind of going back a little bit about where competitive advantage will come from. I In your problem solving, when you problem solving kind of day to day, the models you have to bring or when you're approached with something, how do you parse out if it's something where you need better or higher quality data versus a better method, tool, technique? Like how have you developed an intuition over time as to what will be the key to that problem?
Um, well, so many of the improvements we make are not step functions, right? They are over time. Every month something improves a little bit. For example, we retrain the model with new data. We put more parameters in the model. We re-optimize the hyperparameters. We look at the data again at some statistics and find, oh, the average is wrong. Okay, there's a bug somewhere. In fact, we fix a lot of bugs, right? And you wouldn't believe how many bugs are in these systems. And it is, this is maybe what I meant by this scientific common sense. I mean, look at the whole problem, and where is the most likely way to improve this. And this is not easy, right? And you know, it's kind of a random process actually. You need to try a lot of things. You know, if neural networks don't work, try trees or try linear networks. You know, one thing actually that I just remembered is what I tell often people, because when they start out, they go like, oh, I want to use all this new technology and a big model and, you know, try everything together. And what happens, so they put all this together, and usually what happens is nothing works, right? And then we say, okay, scale it down to 2 parameters and 3 data points and see whether that works. And, you know, often we find actually all the issues by doing that. So scaling down first and then growing bigger is certainly a good general principle to follow.
Thank you.
Turn on your mic. I don't think it's on.
Hello? Okay.
Perfect.
All right, thanks. Yeah, my name is Mike Mazer. I'm an alum. My question is, what are your thoughts on the state-of-the-art in multimodal AI? You alluded to the Fed, so that you can mix news stories with time series data. And also, do you think transformers, essentially everything will gravitate toward that? So we'll be able to use transformers for analyzing time series data?
Okay, so let's address the transformer question first. So I was at Google actually when the people who were sitting next to me were doing these transformers, and you know, transformers are, for me, is just stacked attention, right? So it's one of the 100 things that can go on in neural networks. It's not really, this is not the one thing that made everything work, right? You can use, you know, recurrent neural networks and all kinds of things that are very, very similar. So they have, I mean, it has helped, but it's not the holy grail or something like that. So on multimodal data, 2 Sigma is obviously using a lot of multimodal data. You know, we are scanning news. We are, yeah, sometimes, you know, there are pictures. We look at credit card statements and all kinds of things that happen throughout the day. But it's not, there's no global solution to using multimodal data, right? It's a quite hard process to actually use even 2 sources of data at the same time and do that correctly. So it's, I think a lot more has to happen before that gets like more automated or something like that. We're not at that point.
Hi, I have a question about like training models can be expensive and difficult and time consuming, both in labor and GPUs are super expensive nowadays. More often than not, a model doesn't work. Um, how do you balance that risk? That's a huge risk you're taking each time you train something new, right?
Yeah, that's right. So at Google, we said, or in tech, we said, you know, there's the limit of human patience, how long you can train a model, right? And that is usually 2 weeks. There's a week, between a week and 2 weeks. Longer than that, nobody has the patience to actually run experiments. Yes, it does cost money. You know, the models that we train are a lot smaller than the ones in tech, but it still costs money. And you know, this is a thing that we look at every day. I tell people, you know, don't just run random things, you know, ladders or things like that are useless. Think about what you do. I mean, that's really a key thing. So the other thing that you mentioned is often things fail, and that is just a part of research or development in general, and people just have to get used to fail. And you know, one thing that, especially when younger people join, they're not used to really failing enough because their whole life has been not a failure and up to that point, right? And then because everything was done in 4 weeks, and now sometimes they don't get a result for 6 months, and that's normal, right? That's okay. I mean, that was actually one of my challenges when I first came, to explain to people, not everything you do has to work. You have to take risks to be able to explore some of the things that you know haven't been tried before. And lots of that will not work. It's fine, right? Of course, that cannot go on forever, but it will not. If you keep trying, it will not go on forever. But I think that's That's the thing to get used to. You need patience, with this stuff.
So fail early, fail often.
That's right. I mean, failing is fine. That's necessary.
Go ahead.
Hello. So I have a question. I actually have two questions. So in medicine, allowing AI to make final decisions is often seen as a major challenge due to liability concerns. So if things go wrong, people generally want to see a human being responsible for that. So I wonder if what do you think about this? Does the similar concerns apply to finance? This is my first question. And second one, how do you see the intellectual property challenges of using AI? I mean, who would own the right? The developer of the AI, the user, or maybe the AI itself?
Okay, so the first question is about risk. So in a large company like Two Sigma, obviously, there are all kinds of groups set up to deal with risk. This is also mandated by regulations and stuff like that. And none of that is changing, right? So, when people say, oh, there are all these dangers, actually, I think they're actually less dangerous now to some of those things because we are trying in experiments a lot more things, and the results get better. So it's just more unlikely that something really bad is going to happen in some way, right? The other question was about who owns AI. I mean, who owns technology? Who owns progress, right? It's to me, the tech industry has gone the way of open sourcing lots of things and writing papers about everything and basically inviting everybody in the world to participate. And I think that it was the right decision. It cannot be done the same way really in tech, in finance, because there's too much at stake for some of the companies. But lots of the technology we use is well known. So I'd say we all own it together in a way. There's not a country or certainly not a certain institution will own these things.
Question on the small models that you alluded to. A lot of the small language models rely on the large language models to create synthetic data that the small ones are trained on. So I was curious if that was your approach. And then secondly, Meta, a lot of their PyTorch ecosystem is open sourced. We've played around with things like ExecuTorch to put small models on iOS and Android and take advantage of Metal and things like that. Are you playing around with things at that low level, or is there some other higher level? Like, are you going into CUDA and RockM and VLLM, or like what level do you guys play at?
So on the second question first, we deal with all these levels, right? We use, of course, we are in the midst of TensorFlow, sometimes in the midst of CUDA. As much as we can understand of the whole technology stack, the better it is, right? But when I talked about small models, I didn't necessarily mean LLMs, right? Actually, this is another group at Two Sigma that is doing that. We use all the LLMs that are out there. I can't really specifically comment on small LLMs that are used somewhere. I wouldn't know, right? There are probably some, but currently in my group, no. I mean, in fact, most of the technology we use is not LLMs right now, right? It's the models have 1 million parameters, but those are not LLMs. Those are prediction models for prices and things like that.
Maybe time for one more question.
Mike, great commentary today. My question has to do with a resounding theme that you've said answering questions in your Fireside chat, and it has to do with the fact that models today are relatively limited in just their capabilities across needs. But one of your contemporaries, Yann LeCun, the chief AI scientist at Meta, says that the reason for the limitation of LLMs today is because they could only, for example, ingest text. They're very difficult, as you said, with ingesting multimodal data for inference and training. They don't have context or memory. So in your view, as there's these early research in new architectures, in your ideal state of the world where we do see a much more capable AI, what do these architectures need to have for them to be up to snuff in those ways?
Maybe this is a very general AI question, but one thing that I'm, waiting for is a system that understands more of the physical world, right? I mean, currently it's all just a machine that it cannot see, it cannot hear, it cannot walk around, and get new experiences that way. And I think, so the whole robotics area, if that develops more, that will be a huge help for the whole field, I would say, right? And Yann LeCun is certainly right. I mean, at this level, there are really no models that can just take any information and you just throw it at them and they do a sensible thing, right? That's not the case.
So thank you, Mike. We really appreciate you taking your time and sharing your insights with us today. That is going to conclude our program for the morning. I'd like to more broadly extend our deepest gratitude to all our speakers today for their contributions. I would also especially like to extend a thank you to the DFI team, especially Kathleen Rizzathorn and Julie Berger for making the event possible today, as well as all of our volunteers that contributed to this event. Thank you.